Okay. Ryan brought us a Rivian, and he's going to talk a little bit about another project coming up, but we also have Larry with a technical presentation queued up. Would you like to go, sir?
Sure.
Thank you.
Let me get it running here.
All right. Larry last expounded upon the subject of cabin heating of a conversion, and it was just in time as I got my classic factory Ford Ranger EV running this winter, and that cabin heats up so fast with a pure resistive element heater rather than a water boiler that most of the newer EVs have. So instant defrost, and I love it. Thank you, Larry.
Okay, I'll try not to get damage this. Okay, I put together a PowerPoint regarding a project I did actually a couple of years ago, and it took quite a while. And the whole idea is this, that this is my EV. I took that picture today, and the sun was on it until I clicked. It's a Chevrolet S10 with the extended cab, all that. And I did the conversion and finished it up, started in 2007 and finished it up in early 2008. And how does it run? It runs fine. And I wanted to talk about what happens afterwards, because this is something, some of the things, once you get your EV, the conversion running, and you have the EV grin and all that, driving around, so if something breaks, you're not going to drive it into a Chevrolet dealer, right? So it's kind of on you, and that's sort of descends upon you like a ton of bricks. And got over that. And then also what happens when something sort of wears out? Not the brakes, I can take it in for a brake job, not a problem, I've done that. But my battery pack, which was a lot of lithium cells, and I'll explain it a little bit, was installed in 2011 by Manzanita Micro, and that's been a long time ago. So batteries degrade over time. But what I found was not all of them degrade. And so what would happen if I just replaced some of them, the worst of them? And that's what this project's about. It's kind of limited to that. Got a lot of stories about my S10, but this is just one. So, I titled this then, it's 9 years old, it's older than 9 years now, because I did this in 2020, it was a COVID project. So, and I wanted to pause for a moment from our sponsor, the Advocacy of Electric Vehicles, and Stephen's quote, I'm going to put that on here, converting a gas-burning vehicle to all electric is the highest form of recycling. When I first heard that, I thought, yeah, because at the time, Chevrolet did not make a truck that I wanted to buy. It was just not available. So I got one and converted it to electric. Yeah, I want that. All right, so back to the discussion. Yes.
Right over here, I've got everybody can see a little bit better.
Okay.
Does that work for you?
Yeah, I can be right here. So how do I keep track of the battery and the battery state of charge, of course, and the battery performance over time? And so I have two things. One is this nifty dash display. I got this idea from at the Greenwood car show. I saw it on a car, and it's called eVision, and so I use that, and it'll show voltage and current, and I can select a whole bunch of things. I can even look at my watt hours per mile, all kind of stuff. And so I have that, and then I have this display, and it's not very big, small touchscreen display that came with my battery installation at Manzanita Micro. I added this to it, part of the battery management system. And what this is, it shows a lot. It's a really good system, and it's a stacked bar graph. You know how stacked bar graph, you can have more than one bar over the same bar. And so what this is look at it this way, these are 48 vertical green bars, one for each lithium cell. And 48 lithium cells make my battery pack. That's a 160 volt, 15 kilowatt battery pack. They're 100 amp hour lithium cells. And so I keep track of it with this display. And the height of each green bar is the voltage. And then you see these little lighter blue lines in here. Those are the minimum voltage that that particular cell was during driving. And if you keep driving it, if you drive it real hard, these get pretty low. If you don't drive it very hard, they stay pretty high. And so I can see what I call the saggers. The saggers are the cells that are not performing. They're causing problems. Look at the sagger right here. And I don't remember, I took this picture a long time ago, and but that cell is not performing, right? So when I'm driving, its voltage goes way down, and but the other cells are a little stiffer, we might say, and not sagging so much. So I can look at that every time I drive. I look at that, and I can tell who's performing, who's not performing. All right, and then I can
same
also.
one each time?
Pardon?
Is it the same cell each time?
Yeah, oh yeah. That's when you get a sagger, it'll be a sagger until you remove it. It'll be a worse and worse and worse sagger over time.
Or if you're lucky, you find a loose connection and tighten it.
Yeah.
That can also exhibit.
That might have been this one here. And yeah. And I can also look at an individual cell. I can take a stylus, it's a touchscreen, and I can tap any one of these bars, and this display lights up down here. I can look at cell 7. I see cell 7 right now, as I'm sitting here, is 3.326 volts, and it got down to 3.03, but when I charged it, it got charged up to 3.626, which is a voltage that has been programmed into it. And so this is the display, and over time, now it's been 11 years, over the years, this sagging has got worse and worse. So that's how I keep track of it. Very, very good system, and it comes from Manzanita Micro. If you look at all the circuit boards and everything, it says Redmond this, Redmond that. I mean, there's no question where it comes from. All right, so before the project, this is my reality in 2020, photos taken in 2020. Now look, what do you think there? I magnified just this section over here. So this over here is this section right here. Take a look at that. Look at the saggers now. Yeah, not so hot. And my range was not 50 miles anymore. And even if I have my tires pumped up. So, I thought, and it's been the same 8 saggers all along here. This one, that's pretty bad. Number 1's bad, and you can see a bunch of them over here are bad. So I thought I would like to replace some cells, get this range back. And I can't afford to replace all of them. If I was wealthy, I'd just order another 48. Have Manzanita put them in, bring the car over to me, kind of like I did the first time, but no, I can't do that now. And so I thought, what if I picked 4 bad ones or 8 bad ones? Like if I picked 8, would that improve things quite a bit? Do I have just 8 worse saggers? And I do. If you count along here, it comes out to 8. I thought, I'm going to try that. So I thought, I'm going to have this project where I buy the cells from Manzanita, why them, because I bought the ones from them before, and you can buy them on eBay, but I wanted new cells. I wanted them to be stiff, new, and have a little confidence in it. And so I called up Manzanita, got a quote, and started this project. So the project then is, this is my battery pack here. If you look on the back end of my truck, some of you have seen this at car shows. You look at the back of the truck, it's a big aluminum box in there with a key, a lock on it. Unlock it, lift it up, open it up, and this is what you see. all of this electronics on the top of it is for charging. That's the BMS, and it mostly operates during the last part of the charging cycle. Not going to get into that, but that's quite a bit of electronics there, and it's all cabled together into the charger, and then at the end of the charging process, when all the electronics is happy and all the cells are equal and everything, they take a vote. Say all in favor of shutting off the charger, say aye if it's unanimous, 48. Charger goes off, just the fan is going. That's the way it works every time. I've done that hundreds of times. And so that's 48, and then those who are thinking of conversion, it's some specifications. It weighs 350 pounds, that's what I was told by Manzanita. And there's extra space in there, because in the beginning, said I installed this in 2011, but I did the conversion in 2008, right? So what was in there before were 6-volt lead acid golf cart batteries that weighed 66 pounds apiece. There were 20 in here, see that extra space? There are 20 here and 6 in the front. And I did weigh the truck as about 5,500 pounds. So I'm still underneath the 10,000. But the thing was heavy, but it ran, and it got up the hill, lived up on top of a hill in Kirkland, and this thing had to pull that hill, and it did. So that explains the extra space. Now the weight of the truck is the same as what's on the door panel indicates, so not a problem. Okay, so the project, replace the 8 worst saggers, and I found these. And I replaced all of these. All the cells are numbered. When they installed the cells at Manzanita, they put a number on every one of them. And so I placed those, and the cell type is a gray Calb. Calb is the name of the manufacturer. It's an aircraft battery, essentially. And then I purchased them from Manzanita, came to $1,428. And so lesson learned number 1 is that the price of lithium cells has not gone down since 2011. And but anyway, it was ended up no warranty and no drop ship to my house in Bothell. So I had to hop on a ferry, go over and pick up the box from Rich, and had entertaining conversation as usual, and then came back on the ferry. So my thought was to charge each cell to 3.3 volts. That's kind of fully charged for my purposes. And then in the truck, drive the truck until the batteries the cells are all down to 3.3 volts. And then I would install the 8 new cells, and I didn't want to confuse the battery management system. I just wanted to kind of slip them in there and do it. And so I removed the saggers, replaced with new cell. Well, Stephen, I've misspelled your name, I'm sure. Yeah. But Stephen, I thought, I just want to bounce this off of somebody who really knows what they're doing. And so I called Stephen, and he recommended grouping the cells together at the end of the string so that they would be 41 through 48. I thought, okay, kind of makes sense to me. And so I pulled all of these cells, and then when I put in my 8 new ones, I put them in as 41 through 48. So obviously some of those in that string I moved into the middle of the pack on these, like cell 1, 8, 28, 38, and so on. Okay, and then I would confirm the happiness of all of it by taking it for a drive, charging it up, running through a couple charge cycles, and yeah, worked. Okay, so how did I do it? And charging the new cells, then that was kind of a head scratcher, because I have, with all my ham radio equipment, I've got all kind of power supplies, adjustable power supply, lots of them. And so none of them worked, because I needed a power supply that I could adjust the voltage and current. And there'd be no battery management here. And so what I did is I connected all of them in parallel with a wire that's actually a little too small, but that's fine. And I went on eBay and I bought a 5-volt adjustable current power supply, and you'd be surprised how cheap they are. I think this was like $20 in shipping, that kind of thing. And I think it arrived like in 3 days after I ordered it. It was kind of amazing. So I used that as the source of power. Then I used 2 digital multimeters. One of them connected to measure voltage, and the other I used a current shunt here, and used the other meter then to measure current. So I could set 10 amps charging and set the voltage, I think I set it to 5 volts, something like that, and set this to 10 amps. Then, as you can imagine, 10 amps charging these big fellas is going to take a while. So I just let it run and run and run. And for a long time, it just didn't seem to do much of anything. And then, so thought, I kept checking it. Then one day it came out and removed everything, checked that they're all 3.55 volts, a little too high. So I didn't really watch it that close, right? And then I had to discharge the cells down to 3.3. I didn't want to charge the truck up to exactly 3.55. And so I dug around in my parts bin for power resistors, and then made a circuit that would drain the current off of it, discharge it, and that took about a week, and it got them right to 3.3. I wanted 3.3. The truck, meantime, is sitting outside at 3.3, the whole pack, unsuspecting that I'm going to invade it like this. And so it came to pass then 3.3 for all of these and 3.3 in the truck. So then what I had to do is get with it. And whenever I open up and take off the plastic cover, which you can make that plastic cover that goes over it, some of you have seen it at the car show, and I always have it on there. And you feel safe around it, but when that thing is off, you feel really naked, because just one microsecond of 160 volts at X number of amps, where X can get up to about 600, lethal.
If you
So,
drop a metal wrench in there, it will go incandescent.
yeah, you wouldn't want to drop something, because it would just instantly turn red hot and sparks all over you. So what I did is I did a kind of a chicking out thing, and I removed some jumpers there to make it into not a 160 volt battery, but an 80 volt battery, and then I did a little more undoing of jumpers and made it more in a bunch of 20 volt batteries. But still, you can't drop the tool because the current is there.
I mean, now you can touch it though.
Yeah, I can, and yeah, you're doing a lot of touching here. And so, so I removed the electronics off of it, and that comes off pretty easy. These regulator boards just pop off, and then these larger cards here come off when you remove a terminal. So I removed the 2 cards and the BMS regulator cards off of it, and it leaves these bars. And then the next thing is to take the bars off. And so everything done very, very carefully. In this picture, this is cell 48. That's my positive terminal right there. It goes from here up to the Zilla 1K motor speed controller. And then back here, it jumps over to the other side. These cells are all in series. And so nobody wins the prize. You know what the prize would have been?
Bueller.
Nobody questioned that I called them solid gold bars.
Very expensive pack.
Yeah, it would be.
Silver would be more conductive anyway.
I thought for what I paid for this, the check I wrote to Manzanita, I thought I got gold bars coming.
Okay.
I didn't.
Oh.
I
Had a better salvage value.
That was, so anyway, so all the bars are off, then start pulling the cells out. That's kind of what it looked like while I'm working. And then I put the the new 8 all together, as Stephen Johnson recommended, and it makes sense to me. And then, and some of the cells in here, I moved over to the middle of the pack. I don't show that picture, but that's how I did it. And then started connecting everything together, putting the bars on, and they have washers and things like that. And so I forget what you call it, but it's that goop that makes better connection and prevents corrosion and stuff.
Actually, the opposite of dielectric.
Yeah, I got a whole bunch of it, and
Conductive grease.
I cleaned off the bars. They looked kind of dirty when they were there, but when I took them off, in every case where I took a bar off, cleaned it up very, very well, and then I put new goop on it and everything. I didn't have to replace any washers. There's a whole bunch of copper washers also, and I didn't really know that, and I cleaned those up just as well. So then, question is, was it worth it? So yeah, so take a look at this. I took this one today. Today's March 14th, 2023. So I took this picture today, took it out for a drive today, and I wanted to lean in it really hard. So I went up some hills, really stomped on it, and I gave it just maximum sag. These are the remaining cells, and here's those 8, right? No sag. What if I had 48 of those? I'd be hot rodding all over Kirkland and Bothell, even still. Probably say, I'm skipping the meeting, I'm having too much fun. So, but at $145 a cell, no, I'm not doing that. But anyway, it did work. It worked well. And I would say maybe 3 or 4 charging cycles is all it took for all of them to all be even again. That's not very much. I thought I'm going to have to drive this thing daily for a month to get them kind of synced in, but no, it really wasn't that bad. It went really well. And take a look, while we're looking at that, what about these 11-year-old cells up here? Not bad, right? So there's no question that when Manzanita installed them, they were all fresh batteries. And as I mentioned again, that you can get lithium cells from eBay with questionable background. So anyway, that's it worked out, and so now we're ready for show.
Got a question in the back. Go ahead.
So my pack is similar age, and I'm replacing the whole thing. I just do an upgrade, but I noticed a lot of same things you did, where certain cells were aging faster than other ones. And I've got, over the 9.5 years I was running my Scion, I had 4 spare cells, which I dropped in as certain cells got really bad. So that left me with, I think technically I still have 1 spare because I accidentally replaced an incorrect cell. And it turns out that things were good enough, I just kept going that way. But my earliest cell failure was only at like 10,000 miles, so that was really a bad cell. And I took it apart, it was swollen up at the terminal connection and weird stuff, so it was clearly just bad. But after that, one of about 50,000 miles, and then the next one was closer to 65 or 70. So, and I took the pack out with a little side of 80 on it. So, but I was starting to see a fairly good chunk of cells starting to show up as saggers, as you're putting it, maybe 8 or 9. But my worst cells compared to saggers were probably still only a few amp hours different in capacity. So I guess my question is, the cells that you replaced versus the worst cells you didn't replace, what do you think the difference in amp hour capacity was between those?
I would only guess. I got the unit I have for checking amp hours only works on lead acid. The newer version of it will work on lithium. That's the only way I'd do it. It'd just be a wild ass guess.
Yeah.
If we take a look at this, these are the 11-year-old ones all here, And so comparing, those would be 100 amp hour. We could just say, assume that from,
Yeah.
and then say this sagger here, so I got 4 more, I could replace 4 more saggers. This one here, it comes down that far. Is it a linear relationship? Is it a logarithmic relationship?
Yeah,
I don't know.
I mean, there's a bell curve, right, in everything.
Yeah.
So, the majority of cells are a certain level of health. And there's gonna be a few that are better, a few that are worst. And, you know, if you get too far off on the worst end, there are the cells that are starting to limit your style, right?
Yeah.
So you replace the stuff just on that end, you can keep going for a while, but eventually that peak starts marching over. And, you know, just, you know, I haven't mathematically proven it, but I've sort of figured my biggest batch of healthiest or healthy-ish cells, you know, median cells basically, were at about 70 amp hour capacity, maybe 65 out of the original 100. Whereas the ones I was replacing were down around 60. So, and usually there would be like, as far as I could tell, just by state, you know, by resting voltage when I would get home, I could estimate state of charge. And if I was seeing my worst cell at basically 0, you know, sitting at like 2.8 volts, and the next one up after resting for a couple minutes was at 3 or 3.1. You know, there's, if you look at the discharge curve on a lithium iron phosphate cell, there's only 5%, 3% sometimes between those 2 voltage points. So they're really not that far apart.
It could be you could determine the internal resistance by using the delta V, delta I.
It's kind of a weird thing, is my worst resistance cells aren't my worst capacity cells necessarily. It's different. So I've got some fairly high resistance ones, but they aren't the ones that end up being the saggers. So they sag more when I'm running, but when I stop, they pop back up. And the different cell that wasn't sagging as much until it started getting lower would end up being the one that was limiting
Here's
my
the
range.
recovery on these. All right, the recovery, here's the 8 good ones, and here's what they recovered to, right?
Yeah, they're sitting a little
And
higher
here's
than
all
everything
these
else.
saggers, they all recovered here. When I took this photo this afternoon after the drive, so recovery is not bad.
So I mean, there's several modes to aging on these lithium iron phosphate cells. What I'm getting at is the internal resistance definitely climbs, but some of my best cells are still close to what they were when they were new. But my worst ones, you know, the best ones according to my BMS and some of my own stuff were running around basically about 1 milliohm. My worst ones were when I pulled the battery about 5 milliohms. But even those weren't necessarily the ones that were limiting my range because they still had more capacity. They were just limiting my ability to step on the throttle basically.
But we are limited on time. So, well, thank you, Larry Ryan. We now have Webmaster Ryan.